threads in Java. Okay, as we discussed, we will have four stages in multi-threading: newborn, active, blocked, and death stage. Okay, first work newborn, active. Okay, blocked and death phase will be there in any thread life cycle. Okay, that's what we have discussed in the previous classes. Okay, and even we have discussed how we can send a thread, okay, from one stage to another stage. Okay, now we discuss those theoretical concepts in a programmatic manner. Okay, now I told that each and every thread has a ID and a name. Okay, now how we can get the currently executing thread means using thread dot current thread. Okay, get I'm getting the name of the thread, ID of the thread, plus okay. What I'm just doing is I'm printing the name of the thread, ID of the thread, and the value in the iteration. Okay, just let me try to go to just compile. Let me go to the classes. So thread-0, okay, and thread-1. If you see here, once thread-0 is has completed 999, still thread-1 is 963. So in case of threads, we cannot expect the output. Okay, we cannot expect the output. Multiple threads will be running parallelly. Okay, so we cannot expect the output. We cannot expect how much or how many number of statements executed in a particular CPU time. Let's consider like the CPU time is 10 milliseconds. In one iteration for 10 milliseconds, only 2 statements might be executed. In another iteration for 10 milliseconds, 10 statements might be executed. It depends upon the system load. Okay, so we cannot expect output in multi-threading, but if you see here, ID will be unique. Okay, 7 is the ID of the thread and 8 is the ID of the thread, and the default name provided is thread-0 and thread-1. We cannot change the ID of the thread, but we can change the name of the thread. How we can change the name of the thread? Means set name method. Set name method. Set name method is used to modify the name of modify the default name of the thread. Name of the thread is first and name of the second thread is second. Okay, first and second. Now let me try to compile this application. How we can set the name means using the set name method. So let's compile, go to the classes, execute application. So here now it has been up to 995, but previously it was up to only 960. So we cannot expect the execution in case of threads. Okay, now we have set the name, but it's not advisable to set the values after starting the thread. Okay, whatever the values that we set to a thread, whatever the properties that we set to a thread, we should set those properties before starting the thread. Then only it will be perfectly reflected. But if you set the properties after starting a thread, it's not sure that the properties will be reflected. Okay, it's not sure that the properties will be reflected. But anyhow, if you want to reflect those properties manually in all the executions, it's better to set those properties before starting the thread. Okay, before starting the thread itself, we should set all the properties of a thread. Once the thread is started, we should not modify the properties. After starting a thread, we should not modify the properties of a thread. Okay, now there is another method, get priority, which gives you the priority of a thread. We can set the name of the thread, but we cannot set the ID of a thread. ID should be generated, it cannot be set through the application. Through the application, we cannot modify the ID of a thread. It's unique and it's generated by the JVM. Okay, now let me try to compile this. So the priority of the thread is 5. 5 means it is normal priority. Okay, the priority in case of threads will be represented as integers. Okay, 1 is minimum priority, 5 is normal priority, 10 is maximum priority. Okay, so what's the priority? 5. Okay, and what is the default priority of a thread? What is the default priority of a thread? 5. We should not tell it in the integer format. 5 is normal, 1 is minimum, 10 is maximum. What is the default priority of a thread? But it's not the answer. It should not be the answer. The default priority of any thread depends upon the parent. Okay, the default priority of any thread depends upon the parent. If the parent has normal priority, even the child also will have normal priority. If the parent has high priority, even the child also will have high priority. The default priority of any thread will depend upon the parent. Default priority of any thread will depend upon the parent. Now let me set the priority of the main thread. How we can access the main thread here? In the main method, how we can access the main thread? Huh? How we can access the main thread in the main method? Huh? What? Hmm? What I'm asking? How can we access the main thread from the main method? Using thread dot current thread. Just because in the main method the currently executed thread is main thread. So thread dot current thread will give you the reference of the main thread. Just because in the main method which thread is executing? Main thread is executing the statements in the main method. How can we get the reference of the main thread in main method? By using thread dot current thread. Okay? For the main thread, I can set the priority. Whatever the default priority it might be, just I am setting the priority of the main thread as max underscore priority. Okay, there are final static constants in the thread class which represent the priority. Max underscore priority, min underscore priority, norm underscore priority. These are the final static constants in the thread class which represent the specific priorities. And this data type is integer. The data type of max underscore priority is integer and the value is 10. Okay. The data type of norm underscore priority is also integer and the value is 5. Data type of min underscore priority is integer and the value is 1. So rather than using 1, 5 and 10, we use final static constants. Min, max, norm. What I am doing is I am setting the max priority for the main thread. Okay, so let me save this. Just what I am doing is I am setting the max priority for the main thread. Okay, how we can set the priority means using thread dot max underscore priority or min underscore priority or norm underscore priority. Okay. Then what is the priority of the child thread generated? 10. Just because it gets the priority from the parent. Okay. The priority for the child thread is also maximum. Just because by default okay, the child thread will get the priority from the parent. It's not normal, okay, it depends upon the parent. If the parent is high, even the child thread also will have the high priority. Understood? It will be like that. And so we can modify the priority for any thread, and but that should be done before starting the thread in general. Just for T1 I am setting minimum priority. Okay, for T1 I am setting minimum priority. And for main thread I am setting maximum priority. For main thread I am setting maximum priority, and for T1 I am setting minimum priority. So what will be the priority of T1? Definitely it will be minimum. Whatever the priority we set, that will be override the default priority. But for T2 definitely it will be maximum priority. T1 it will be minimum and T2 it will be maximum. Okay? Just because if we don't set a priority, then it will get the default priority from the parent. Now, which thread we started first? First we started first thread or the second thread? First thread. But which one is ended first? Second thread. That means second thread has been given more priority in executions. Even though we have started the first thread first, the second thread is completed first, just because in multiple executions from runnable to running, okay, or active to something in any other phase, the second thread has given more priority. So second thread has completed first. Even though the first thread has started first, second thread has completed first, just because it has more priority and it might have given, okay, preference in the competition. Okay, that's how the priority will play a role. Okay, but the priority doesn't define how much time the thread is there in the running phase. It's defined by the CPU time. Okay. And this is how we can modify the priority of a thread using set priority method. And rather than going for, but it's always advisable to go for min, max and norm priority, which is there in the thread class as final static constants. To set the priority, is always advisable to go for thread.min underscore priority or max underscore priority or norm underscore priority. But we can go for even integer values 1, 5, 10. But this is not a standard way of setting the priority. Okay? Okay? 1 means minimum. One is minimum. Okay? One has minimum priority. Okay? And let's consider, like, if I give 4. What's the priority? So we have only 3 ranges of priorities. Okay? Minimum, normal, maximum. But instead of 1, if I give 4, what's the priority? Will it be normal or will it be minimum? See, 1 is in general, 1 is minimum, 5 is normal, 10 is maximum. That as per the thread representations. But if I give 4, what will be the priority that is set? Will it be minimum or will it be normal? Hmm? No. We are not using default priority, we are overriding the priority by using 4. But what 4 indicates? Whether it indicates a minimum priority or normal priority. Let us see. It's indicating it has 4, but up to 5, whatever the priority that we give, it is minimum priority. Okay, 5 is normal, and again 5 to 9 is normal, 10 is the maximum. Okay, 1 to 4 is minimum, 5 to 9 is normal, 10 is maximum. But we should not give 1 to 4. We should give either 3 values, 1, 5, 10. We should not give the integers in the middle. Okay? That's why it is always advisable to go for max underscore priority, min underscore priority, or norm underscore priority. We should not give integer values, but some of the interviewers will be asking, what happens if I give 4? Even 4 will be considered as minimum priority. Up to 9 it will be considered as normal priority. Okay? Okay, understood? So, while setting the priority, we should not use direct integer values, we should use only the final static constants in the thread class. That's the advisable approach. Okay, and what are the different types of threads that we have in the application, in the Java application? Basically, there are two types of threads that we can have in a Java application. Okay, one is user thread and Daemon thread. There are two types of threads in the application. One is user thread and second one is a Daemon thread. User thread and Daemon thread. Okay, what is a user thread and what is a Daemon thread? Okay, let us see by an example. Let me have. Did you read this? Daemon, D-A-E-M-O-N, Daemon. Okay, there are two types of threads in Java applications. Okay. One type is user thread, the second type is Daemon threads, and we'll see what are those threads, what does those threads mean. Now if I am not starting T2, what are the number of threads present in the application? Only one, T1. Okay, the child thread present in the application is only one. Even main thread also will be present. Okay, the child thread will be only one. Okay, now what I do is, in the main thread I'll execute 1000 statements. Even in the main also, I execute 1000 statements. Now, here I execute only 100 statements. Sorry. In the main thread, I execute only 100 statements. In the main thread, I execute only 100 statements. But in the child thread, I execute 1000 statements. Okay? Now, let us see how it happens. Now, is this the last block of execution in the main thread? Is this the last block of execution in the main thread? Yes. So when the main method execution is completed, the main thread will be expired. Okay, main thread will go to the death phase. So if I execute this, now when the main thread goes to the death phase, that means when the main thread is expired, when the main thread execution is completed, now is the child thread expired? No, the child thread is not expired. Okay, the child thread will not be expired until its execution gets over. Okay, that means is the child thread depending upon the main thread for its execution? Is the child thread depending upon the parent thread for its execution? No. Okay, if that is the case, then the created child thread is called as a user thread. Okay, the created child thread is called as a user thread if the execution of the child thread doesn't depend upon the parent thread. The created child thread is called as a user thread if the execution of the child thread doesn't depend upon the parent thread. And if the execution of the child thread completely depends upon the parent thread, if the execution of the child thread completely depends upon the parent thread, then the created child thread is called as a daemon thread. If the execution of the child thread completely depends upon the parent thread, then the created child thread is called as a daemon thread. Okay? Now, we cannot create a daemon thread in a Java application. We cannot create a daemon thread directly in a Java application. We cannot create a daemon thread directly in a Java application. If you want to have a daemon thread in a Java application, then what we need to do is we need to create a user thread and convert into a daemon thread. But it's impossible to create a daemon thread directly in a Java application. What we can do is we can create a user thread and modify that user thread to a daemon thread. Okay? By default, all the child threads are user threads. By default, all the child threads are user threads. By default, all the child threads are user threads. And how we can make a child thread as daemon thread means, okay, by making a flag set daemon. We are setting the daemon flag as true. If we set the daemon flag as true, then the user thread will be converted into a daemon thread. The user thread will be converted into a daemon thread if we set the daemon flag as true. But we should set all these things before starting the thread. Then only they will be applicable. Okay, we are making a set daemon as true. Then the user thread will be converted into a daemon thread. We cannot create a daemon thread directly in a Java application. First, we should create a user thread and convert that user thread into a daemon thread. So let's see the difference. How the user thread and daemon thread will be changing. What's the difference? What's the difference between user and daemon thread? See, if you see here, previously when the thread was not a daemon thread, when the thread was a user thread, the whole statements of the first thread are executed. But now, are the whole statement of the first thread executed? Only 133 statements are executed when there are 1000 statements. But let me do the same application by commenting this. How this line makes a difference? Just let me comment this, okay? And let me compile and execute the application. If you see here, all the statements of the first thread are executed. That means all the 1000 statements are executed. Okay? But if you make the thread as a daemon thread, what happens when the parent is terminated? When the parent is terminated or when the parent is expired, automatically even the child also will be expired irrespective of the status of execution. Irrespective of the status of execution, a daemon thread will be expired automatically when the parent gets expired. Okay? So that kind of thread is a daemon thread. And we should not modify the daemon flag after starting the thread. We should not modify the daemon flag after starting the thread, which is not advisable. Once the thread is started, we should not modify the daemon flag. Here I have, now how I can convert a user thread back to a daemon thread means, a daemon thread back to user thread means by setting the daemon flag as false. Set daemon true will convert a user thread to daemon thread. Set daemon of false will convert a daemon thread to user thread. Set daemon of false will convert a daemon thread to user thread. Set daemon of true will convert a user thread to a daemon thread. So, let me try to compile the application. Let's compile, go to classes and execute it. What is this giving? It's telling that it is a illegal thread state exception. Why it is giving illegal thread state exception means we are setting the daemon flag after starting the thread, which should not be set. Okay? We should not set the daemon flag after starting the thread. So whatever the properties that we set to a thread, we should do that only before starting the thread. Okay. Today some of the guys are having interviews, so we will wind up at 7:15 only. Okay. Okay, understood how the daemon flag will make the difference? And a daemon thread cannot be created directly. We should create it explicitly. Okay, we should make we should convert a user thread into a daemon thread, and there is a method named join. There is a method named join. I think join will raise a checked exception. Let me see. I don't remember exactly. Yes. Join execution will raise a checked exception, which is a interrupted exception. Join method will raise a checked exception, which is a interrupted exception. Let's see, after adding join, what happens? Just in try catch we have added t1 dot join. Okay. What happens? First, okay, the first thread will be given preference, then the parent thread will be given the preference. First the child thread will given the preference, and then the parent thread will given the preference. Okay. What we are telling by join means, okay, by join method we are telling that, okay, even though it is a Daemon thread, okay, even though it is a Daemon thread, okay, don't expire this thread or wait the parent thread until the execution of child thread is completed. Just by executing join method, okay, we indicate the runtime environment that don't expire the parent thread until the execution of child thread is completed. Let's consider like the parent thread is having 100 statements, the child thread is having 5000 statements. Then which one will expire first? Parent thread is having 100, child thread is having 5000 statements. Which one will be expired first? Definitely the parent thread will be expired first. But by executing join method before starting the thread, we are telling to the runtime that please don't expire the thread until the child thread execution is completed. Even though it is a Daemon thread, even it will not, join method will not convert Daemon to user thread. Join method will not convert a Daemon thread to a user thread, but it will indicate, it will give an indication to the runtime environment that, okay, it should not expire, the runtime environment should not expire the parent thread until the execution of this particular child thread is completed. It gives an indication to the runtime environment that the runtime environment should not expire the parent thread until the joined child thread is expired. Just it gives an indication to the runtime environment that the parent thread should not be expired until the joined child thread is expired. So the main thread or the parent thread will be there until the joined thread, child thread expires. But join method will not convert a Daemon thread to a user thread. It will make the parent thread alive. It will make the parent thread alive. The join method will make the parent thread alive until the child thread expires, even though it is a Daemon thread. Understood? No. Join method is for set names as priority. Daemon thread, user thread, and the next one is, okay, these are two types of threads and there are two ways of creating a thread. Okay, there are two ways of creating a thread. Right now we have seen only one way. There are two ways of creating a thread. Which one is better means?
If you take one thread with the user, there is a ruling, there is a ruling difference. That means it is not different there. But if they are different,
parent. That depends upon the requirement. Just because if we have some resources to be, if we have dependent resources on the parent, then always it was advisable to join. Let's consider like parent is one entity and child thread is one entity, and they are completely independent. There is no meaning in joining. It's better to leave it as a user thread only. It's better to leave them as independent entities, independent threads. Okay? If the child thread has some dependency on parent, and if the child thread is a daemon thread, then we will join. Okay? Okay? There are two ways of creating a thread using thread class and using runnable interface. Thread is a class and runnable is a interface. Now, up to now, which approach we have used? First or second approach? We have used the first approach. We have used java.lang.thread to create a thread. Now let me use the runnable interface to create a thread. Class another thread which implements with runnable interface. Runnable is interface, so we need to implement runnable interface, and just in the run method, let me go for a simple system.out.println. Just I am telling that I am in the my thread. Okay, and I will do the same thing even in the just I am telling that I am there in another thread. Okay, I have two threads. One is my thread and another one is another thread. But my thread extends to thread, but another thread extends to another thread implements runnable. Okay, another thread implements runnable. These are two different threads created in two different approaches. My thread is using thread class and another thread is using runnable interface. Now this another thread class, okay, my thread class has start method just because it extends to thread, right? See, in the thread class all the methods are there. Set property, get property, or set priority, get priority, join, start, stop. Okay, all the methods are there in my thread class just because it extends to thread. Now, do we have start method in another thread? Do we have start method in another thread? The only method that is there in another thread is run. Just because the only method that is present in runnable interface is run. So we don't have any start method, okay, or set priority, or set name, get priority, get ID. All these methods are not there in the runnable interface. All these methods are specific to the thread class. So in the runnable interface, the only method that is present is run. So let me remove this and let me remove the join. Okay, otherwise let me comment it out. Just I am commenting the application. so that it can be used for future purpose. Now let me make a very simple thread. Let me remove event T2. Let me not set event name, not required. Now I have created a thread. I have created a thread which is a very simple user thread. Okay, and I'll create even another thread. Now, can I execute start method using this? Can I execute start method using this? Another thread? No, just because the another thread implements runnable. From runnable interface we get only one method inherited, that is run. Okay, so we cannot execute the start method. See, start method doesn't exist in the AT, another thread. So how? At the same time, it will allow us to compile even we don't override the run method. Let's see here. Just I cut this. Okay. Now, if you don't override the run method, will you allow that in case of thread class? If you don't override the run method, will it allow you to compile if you extend to thread class? Definitely yes. Just because in thread class, run method is a concrete method, and thread class is not an abstract class. It is a concrete class. So in thread class, run method is already overridden. Okay. So we may or may not override the run method in the extending thread class. In the child thread class, we may or may not override the run method. But will it allow in case of runnable? Will it allow in case of runnable? No. Definitely we should implement the run method. Otherwise it will not compile. Okay? It's telling that it implements a runnable interface and did not implement the run method. So the thread, okay, for the child thread class, okay, the compiler enforces that we should override the run method. But in case of thread class, okay, the compiler will not enforce to override the run method. But in case of runnable interface, the compiler enforces to override the run method. Okay. In case of extends to thread, the compiler will not enforce to override the run method. We may or may not override the run method. But in case of implementing with runnable, the compiler will enforce to override the run method. Okay? And we don't have any start method in the runnable interface. Then how we can start a thread which is created using runnable interface? How we can start a thread which is created using runnable interface? Okay? Now we need to create a thread class object. Then using this thread class reference, we need to execute start method. This is how we need to do if we go for a runnable interface. This is how we need to implement multi-threading if we go with a runnable interface. Okay, now this is how we can go for a thread by using runnable, and this is how we can go for a thread using thread. So if you try to compile this, sorry, you need to go for a search 21, sorry. Let's compile, go to the classes, execute application, sorry. So my thread and the thread are parallelly executed. Okay, so there are two threads created, one is in one approach and another one is in another approach. Now which approach do you think it is better? Like extending the thread class or implementing with runnable interface? Which one do you think it is better? Thread class? Okay. Any other answer? Which one do you guys think is better? Which approach is better? Whether going for a class which extends to thread or whether going for a class which implements with runnable?
They are writing something for some application. But with runnable, it is not available. Give the initial error, so it is better, add. But with the thread, you don't know what is happening.
Yes, that was a great advantage, but that is not the primary advantage. That's really very good advantage, but that's not the primary advantage of going for a thread class which implements runnable. There are a lot more advantages, but really that was a great answer. Okay, think even in better scenarios. Let me do this so that you can understand it better. How and why. If you want to create multiple threads, then what we do is we use the same child thread class object and we create multiple objects to thread class. Then, which one do you think it is advantageous? Leave about enforcing the run method. Okay, which one do you think? If you compare these two classes, these two approaches, which one do you think it is better? Only two objects. Let's consider, like, if I am creating 100 threads. If I am creating 100 threads, what happens? 100 objects to child thread classes are created. Okay, that's the real thing. If I want to create 100 threads, I need to create 100 objects to the child thread class. But how many objects I need to create? How many child thread objects I need to create to say? If I go for the first approach, what I need to do? If I want to create 100 threads, I need to create 100 objects to the child thread class. But if I go for the second approach, okay, how many child thread objects do I need to create if I want to create 100 threads? How many child thread objects I need to create if I want to create 100 threads? Only one. Then which one is the advantages? Creating 100 child thread objects or creating only one child thread object? Definitely, in any perspective, okay, going for a thread class which implements a runnable interface is always advantageous. Okay, the first reason and very foremost reason is if we extend to thread class, then the class is specifically a thread. Now, if we extend to thread class, can we extend my thread with any other class? If we extend my thread with the class thread, can we extend the my thread class with any other class? Can we extend my thread with any other class? No. So we are enforcing that this my thread should be specifically a thread. That means my thread is used only as a thread. That means we are restricting my thread that, okay, my thread should be used only as a thread. Okay, that is the first disadvantage. We are enforcing that my thread should be used only as a thread. But are we enforcing such kind of things for another thread? Can I extend another thread with any other classes? Yes. That means another thread can be used as a thread as well as it can be used for other purposes also. That's a very advantage of using implements runnable. The thread class can be used as a thread as well as for other purposes also. But if you extend to thread class, the child thread class will be enforced to be used only as a thread. That is the first advantage of going with runnable interface. If the thread class extends to Java.language thread, the child thread class is enforced that it should be used only as a thread. But if it implements with runnable, we are not enforcing that it should be used only as a thread. It can be used as a thread as well as for any other purposes. And the second advantage is the number of child thread objects that we create to create multiple threads. Let's consider like if we extend to thread class, and if we want to create 100 threads, if I want to create 100 threads to my thread class, then how many thread objects do I need to create? If I have my thread which extends to thread, and if I want to create 100 threads, then how many thread objects do I need to create? 100. So let's consider like the child thread object contains 50 properties. Okay, child thread object contains 50 properties, 50. So what happens to the memory? It will be increased like anything. So if I go for the second approach, implements runnable, if I want to create 100 or even 1000 threads, only one child thread object is enough. Okay, only one child thread object is enough even to create 1000 threads. So in that perspective also, second thread is that means going for a thread class which implements runnable interface is better. But memory will not be the same, right? The thread is a very lightweight object. Thread class object is a very lightweight. It doesn't have many properties. But if my thread has 10 properties, what happens? There is a chance for having multiple properties in the my thread, but there is no chance of increasing the number of properties in the thread class. It's already predefined. And the third advantage is the advantage that we discussed just now. Okay? Enforcing overriding the run method. If implements Runnable, it enforces to override the run method. So that there will be some business logic for the thread. We will be enforcing some business logic for the thread. But in case of thread, that kind of enforcement will not be there. Okay? Understood? And from now onwards, if you are creating a thread, you should create thread using only runnable interface. Don't use thread class. Okay? For interviews, I have told thread class, but from now onwards, only use runnable interface to create a thread. Don't use a thread class. Okay? And let's find out for the day. Okay? And in the next class, we'll discuss about synchronization, which is a very, very important concept for interviews. Okay? And the next class will be tomorrow morning, 8:30. Okay? But if there is any urgent work for me, okay, and which is unavailable, I'll inform you through Facebook. Otherwise, there will be a class at 8:30 tomorrow morning.